In this particular section, we're going to take a look at a problem that deals with the difference of two squares, but maybe looks a little bit more challenging. So we're going to go ahead and take a look at the following. So 121 a squared minus 144 b squared. Now, what might make this one challenging is the fact that you need to wrap your head around the fact that each term is actually a product. Okay, so 121a squared is one value. The reason why we can't really simplify this any further is because we're working with a constant and a variable. So we can't actually merge them any more so than what we have here, that it's just the number 121, or the constant, times that variable or that mystery number a squared. So one thing that we want to note here is, let's break this up piece by piece. So taking a look at the constants, 121, you might want to see if 121 is the square of some number, or the product of a number times itself. And if you have gone through a list of numbers before, or if you kind of putz around on your calculator, you'll find that 121 is actually 11 times 11, or we would say 11 squared. 144 probably looks slightly familiar, and that is 12 times 12, or 12 squared. So really what you have here is you have 11 squared a squared minus 12 squared b squared. And we can kind of use what we had learned about exponents and actually go in reverse. So if I have an 11 squared and an a squared, we can actually write that as 11 times a squared minus, and then we can reproduce the same idea doing 12b squared. Because if you recall, we can actually, when we are squaring this product, we can actually distribute essentially that square to each factor. Okay, so that's why we're able to write this, what I have listed in purple, in that way. So again, if you kind of note here, we have 11a squared minus 12b squared. So what I'm essentially saying is I have a squared term minus a squared term. So this must be the definition of the difference of squares. So that allows me to go ahead and factor this out. So I know that I can create two binomials, and I know that 11a squared would just be 11a times 11a, and then my 12b squared would be 12b and 12b. But then note that you have that difference sign, so really you can kind of look at it and say, well, in order to get that negative sign, if I were to FOIL this out, I would need one value to be positive and one value to be negative. Now bear in mind also that if you had written this in the other direction, so if you had done 11a minus 12b times the quantity of 11a plus 12b, that's fine. That's just your commutative property at work. That's why it doesn't matter which one is written first. And also, just to remind you, if you are not sure if you have factored this correctly, you can go ahead and FOIL this out. So we would do our first. So 11a times 11a would give you 121a squared. And then our outers, so 11a times negative 12b, that's going to give us, you may want to refer to your calculator unless you are brilliant with multiplication. That's going to give you 132ab. Then we'll do our inners. So 12b times 11a gives you a positive 132ab. And then you have positive 12b times negative 12b, which will give us a negative 144b squared. And this is exactly what you want to see happening. Essentially, if you're factoring this, you want to get back to the original problem that we were looking at. And lo and behold, if you took a look at this, you see that negative 132ab and a positive 132ab will cancel each other out. And that does take you back to the 121a squared minus 144b squared. So we did factor this correctly, and So our final answer to this question is what I have boxed in the gold color. All right.